This is AI Podcast. I'm Ben, and today we're talking about a new EMNLP 2025 paper called Beyond Outlining. It asks a simple question with big implications. What if long-form writing with AI shouldn't start with a fixed outline at all?
So instead of write an outline, then fill it in, they're saying try something else. Who wrote this one?
Led by Ruibin, Xiong, and Yimeng Chen, with collaborators connected to KAUST. Their system is called Right Here, and the headline is pretty direct. Treat long-form writing as a living, evolving plan, not a one-and-done blueprint.
Living plan sounds nice, but what problem are they really tackling?
The usual pain point. When we ask a language model to write something long, we often force it into a rigid outline. That outline freezes early decisions. If new facts pop up, or the narrative needs a twist, the system struggles to adapt. You get shallow sections, repetition, or contradictions.
Right, like promising a chapter on climate policy and discovering halfway through that your sources push you in a different direction, but you can't easily reshuffle the structure.
Exactly. The paper's pitch is that long-form writing is really three kinds of work woven together: retrieval to find information, reasoning to digest it, and composition to actually write. Their key move is to label every subtask as one of those three types and then break big goals down recursively.
Heterogeneous recursive planning. That phrase looks intimidating on paper. What does it mean in practice?
Think of it like a film director with color-coded scene cards. Blue cards mean go research something. Yellow cards mean think it through and decide what it implies. Green cards mean write. You start with a top card, say write a report on microplastics. Then you split it. Find sources on health impacts, reason about conflicting studies, draft the introduction, and so on. If a new study appears, the board updates and the downstream writing tasks adapt.
So it's not outline then write. It's plan while you write and write while you plan.
Yes, interleaved. They run the whole thing as a directed graph, basically a to-do list with arrows. When a research task finishes, it unlocks a reasoning task, which might revise a writing task. The system moves forward whenever a piece is ready, rather than waiting for the entire outline to be locked.
I like the kitchen analogy here. You don't cook a big dinner by drafting a full minute-by-minute plan and sticking to it no matter what. You taste, adjust the heat, swap herbs when the sauce is going sweet. This system tries to give the model that kind of flexibility.
That's the spirit. And because every node has a type, they can use type-specific prompts. Retrieval nodes get prompts tuned for searching and citing. Reasoning nodes get prompts for synthesis and decision-making. Composition nodes get prompts for coherent prose.
Okay, what did they test to show this is more than a neat diagram?
Two main settings. First, fiction, using a story benchmark where models write multi-thousand-word narratives. Second, technical reports, using a real-world corpus of topics that demand heavy retrieval and structured writing. And they also looked at very long reports, the kind that stretch past 10,000 words to see whether the approach scales.
What were they comparing against?
Against strong outline-first systems. For stories, a collaborative planning and writing setup known in the community. For reports, methods like Storm and CoStorm that build a detailed outline and then write section by section. They also ran ablations, turning off the recursive part or removing the task types to see what actually drives the gains.
And the verdict?
Consistent improvements. Judges favor the new system for overall quality and especially depth. In stories, it helped with plot development and language flow. In reports, it improved relevance and breadth. But the standout was depth, meaning how well the model dug into the topic rather than skimming. The ablations were telling. When they removed the typed, recursive planning, quality dropped.
So the type labels and the recursion aren't just lipstick on the pipeline. They carry the lift.
Right. And the wins held across different backbone models, not just one lab's favorite system. They even showed the approach staying competitive on very long reports, the kind where brittle outlines usually crack.
Let me sanity check the intuition. If I'm writing a chapter on, say, river restoration, a retrieval node might find a new study about sediment transport. That triggers a reasoning node to weigh the evidence, which then tells a composition node to adjust the section on dam removal trade-offs. The graph updates, downstream text gets revised, and I don't have to bulldoze the whole outline.
Perfect illustration. And because the scheduler interleaves tasks, you don't stall the entire project waiting for every source to be collected. You can write parts that are ready, then loop back as the plan evolves.
Sounds great, but I can already hear the practical question. How expensive is this dance of nodes and prompts?
Good question. The paper notes the overhead. Recursive planning creates more steps, and specialized prompts add cost. They point to future work like capping recursion depth or routing simple subtasks to smaller models. It's the classic trade-off, better structure versus more tokens.
What about evaluation? Who decided the winners?
A mix. They used LLM as judge with established rubrics plus targeted human studies. That's common in this area, but it raises familiar concerns. Model judges can bake in bias, and small human samples limit how far we can generalize.
So progress, but with caveats. Any other limitations the authors call out?
To that matter, first, the system is fully automated, with little room for a human editor to steer the plan mid-flight. Given this is a planner, it seems natural to let a person nudge specific nodes. Second, while the graph offers traceability, we still need better tools to debug it. Seeing the plan is one thing. Knowing which node made the narrative drift is another.
Let's widen the lens. Why is this a big deal beyond this one paper?
Because it reframes how we think about long-form generation. The default for years has been outline then write. This shows that mixing planning and execution can make writing more faithful and less brittle. It's closer to how expert writers actually work. They research a bit, reason a bit, draft a bit, and keep looping.
I like that it breaks work into clear types. Retrieval, reasoning, composition. That gives us places to plug in safety checks. For example, before a composition node prints confident prose, a reasoning node could verify citations, or a retrieval node could recheck claims.
Exactly, and it opens the door to smarter collaboration. Imagine a newsroom where a reporter acts as the retrieval node for a tricky source, an editor plays the reasoning node to weigh evidence, and the model handles composition under guardrails. The graph becomes a shared workspace.
If you had the steering wheel for future research, where would you drive this next?
3 directions. First, tougher evaluations, larger human panels and diverse judges to reduce bias. Second, cost-aware planning. Learn when to recurse deeply and when to keep it shallow. Third, human-in-the-loop controls. Let users pause the graph, tweak assumptions, or pin facts before the next wave of writing.
I'd add multilingual tests. The typed approach feels promising for languages where discourse structure differs. If the planner can learn language-specific templates for reasoning and composition, we might see big gains outside English.
Great point. And there's also domain breadth. Legal, medical, education. Each has different tolerance for uncertainty and different citation norms. The type labels could help integrate domain-specific validators.
Before we wrap, one more plain English example for listeners. Suppose I'm generating a long technical report about battery recycling. How would this play out?
The top goal splits into a few retrieval nodes, like collect lifecycle data and map regulations by region. Reasoning nodes digest that data, say reconciling conflicting yield rates. Composition nodes draft sections on processes, policy, and environmental impact. If a retrieval node finds a new policy update in the middle of writing, the scheduler flags the relevant reasoning node to reevaluate, and the composition node rewrites the policy section. The rest of the document keeps moving forward.
So you get momentum without sacrificing adaptability. That's the magic trick.
Yep, and the experiments suggest that this trick translates to better depth and coherence in practice.
All right, quick takeaway for folks on a commute. Long-form writing with AI works better when you treat it as a graph of small typed jobs that plan and execute together. Not outline first and pray, but adapt as you go.
Well said. Beyond outlining argues that the path to better long pieces is not a bigger outline. It's a smarter loop between finding, thinking, and writing.
That's our show. If you enjoyed this, share it with a colleague who keeps fighting with rigid outlines. I'm Priya.
And I'm Ben. Thanks for listening to AI Podcast. See you next time.